Okay, so in this screencast, I'm going to step through setting up an Ethereum development machine on an AWS instance. So I'm going to step through this pretty quickly. You can either follow along even if you don't know much about AWS. If you're curious, go do a little research on your own. So just really quickly, if I go to my EC2 instance or EC2 dashboard, I've already created a security group and I've already created a key pair. Just real quickly, if you're new to security groups, I'll just show you. Security groups is a glorified firewall settings for your instance. And the only things we need are a custom TCP rule for port 8080 using your public IP address, an SSH on port 22, same thing for your IP address, and another custom TCP rule on port 8545. This is what TestRPC uses. And TestRPC is the thing, it's like our fake geth node. It's the thing that, as a developer, we're going to be able to issue commands against it, and it's going to behave as if it's on the blockchain. So again, coming back to my dashboard, I tend to like to have those things in place before I start launching my instance. I don't know, personal preference, I guess. So let's go to launch instance. I'll go to community AMIs, and I'm going to pick Ubuntu, and I'm going to choose this instance, Ubuntu Xenial 16.04. Click select. You are going to need a 2-processor machine for this. Don't try and do it on a T2 micro. It's not going to work. This will run you about $70 a month if you use it very little. So you're going to want to make sure you turn it off or delete it if you're not using it. So anyway, there's that. I'll click instance details. I'm going to accept all the defaults. Add storage. I mentioned before, we're going to use TestRPC, which is like a fake geth node that's actually not writing tons of data to disk. It's not doing a ton of stuff. So for that reason, we can leave this at 8 gigabytes, which is nice. It keeps the cost of this thing a little bit lower. If we wanted to do something like create a true geth node running on the Ethereum blockchain, you need a much bigger disk. If you wanted to set up a private blockchain, you need a little more disk space here. Add tags, if you want. I'll just add a tag for name, Ethereum demo 1, I'll call it. Biggest security group, so I'm going to select an existing one. We already created this one, and the rules are down here. We already talked about it, so click review and launch. And I'll click launch again. It's telling me to select my key pair. I've already created this. I have this file downloaded. So I'm going to click launch instance, and this will just take a minute or two. So if we click view instances, we can see it's getting started right now. And you can see I have 2 instances already that I've terminated. I ran into some problems a little earlier when I was doing this, so I'm going to call this Ethereum demo. I'll just leave it like that. So this one's already running, so that was quick. The only thing we need to continue is if we look down in this information down here, I'm going to grab the public IP address because we've got to configure our SSH client to access this. So I use Bitwise. You can download it, it's free. But it's basic SSH access, so use the tool you like. So I'm just going to paste in my IP address on port 22. I'm going to set the username to Ubuntu, and our authentication method is going to be public key. That's, again, Amazon sets everything up using, you have to have a key to access your Ubuntu instance. So I'm going to leave it as public key. And just to step through the process of importing that client key, so the first time you do that, you're going to click public key and there's going to be nothing to click here. So you got to go to the client key manager. I'll remove this one just so we can step through it again. If I click import, and here's my key. So that was the key pair we looked at in my AWS console. So I'm going to double click that, and I'm just going to give it a name. You can use the same key for 5, 10, 15, however many instances you want, or you can create a separate key for each instance. Regardless, I like to put a name for it because when you have 5 or 10 of these, it gets real confusing when you come here which key to use. So anyway, so I just put that key in here, and when I click, oops, I'm already logged into another instance. I need to abort that. No. Man, oh man. All right, let me do this again. this should go a little quicker. So there's my IP address, Ubuntu public key, Truffle 1. Everything's actually set. So if I wanted to just verify we're using the same key, I think we're good. So I can close this. When I click login, we're good. So it's telling me to accept the certificate. It launches a fairly crappy FTP window. Let me get that out of the way. And right now I have access to the server. If I were a better developer and server administrator, I would probably lock this server down, create another user, and rather than using the Ubuntu user, but I'm not going to worry about that for now. We are pretty much done with the AWS console, so I can close that. Also, I know I'm going to need 2 more windows. Yeah, so let me just open up another window, and we'll do this. So coming back to my document, so again, the first half of this I've stepped through creating the instance, and we're at this point. We already configured SSH, and now we're ready to start installing stuff. So real easy stuff. We're just going to do sudo apt-get update. That takes a minute. Okay, and I'm going to make a directory called resources. Now the thing that's wonderful about the developer community is everyone's so willing to share so much information. So there's 2 repos we're going to look at that are going to make our lives very easy. Let's take a peek at this first one. So let me open up my window, and this is provided by these guys. I took a class here in the spring, and they're one of the few sites that offer a full-blown Ethereum developer course, and they are really smart. It's the technology changes so quickly. I feel like even though I took the course, I still feel like I'm way behind the 8 ball, because now that Truffle version 3 is out, I'm struggling with some of the stuff. So it's best to stay up on your skills. Don't do what I did. But anyway, I just did want to mention that because they are the ones that are making my life easy right now by continuing to share these repos. So if I come into this one particular repo and I look at this bootstrap.sh file, this has all the commands we need to run to install all the dependencies we need to run Ethereum. So by running one file, we're going to get all of that installed. So that's good news. That's making our life very easy. So let me come back to my console. So here we are. So if we go into resources, and let me come back to my document, and we're going to clone this repo, and we're going to clone this repo. We need 2 of these. So, oops, and I didn't put it in the resources folder. So, all right, that's a little sloppy on my part. It's not going to affect too much leaving them here. Regardless, if let's just keep this train moving. And if I go into this this one, we're going to see that bootstrap file. So I would basically need to execute this bootstrap. So sudo bash bootstrap.sh. I think that should do it. So this is going to take a few minutes to run, and while that's running, let me talk about line 7 in here, because ultimately what we're going to do here is this instance that we're setting up needs to do 2 things. One, it needs to behave as if it's a node on the Ethereum blockchain, because we want to, as a developer, we want to be able to write code that's going to issue transactions against that node. So half of this is running something that is acting like it's on a blockchain, just like I said. So if we wanted to do this the long, hard way, an expensive way, we would actually set up a whole Geth node on the real blockchain. It would take 2 days for that thing to get synchronized and set up and running. It would churn through a bunch of disk space and gobble up a lot of CPU resources. Once we get that set up, we'd have to create an account and start mining. You can't really do anything unless you have Ether. Then we'd have to go through this process of when you're working on the true blockchain, you've got to unlock your accounts, and you know it's a bunch of extra rules associated when you're working on the real blockchain. But one of the nice things about this repo is they have two scripts in here that are going to make our lives very nice. One is, if we wanted to launch a true Geth node, what they have in here is a script that actually sets up a private single node blockchain, you know, Geth. For all intents and purposes, it behaves as the blockchain. It's just a private network with one node, and that's what this does. What it does is it's saying, okay, create a Genesis block. They just happen to call it Net42. That's the name of the network. So right there is your own private little blockchain. So as you get better in your Ethereum development, so first do your development on test RPC. I'll show you what that script looks like. But at some point you want to issue your commands against your own private blockchain. And the reason is this thing's nice and slow, just like the real blockchain. And when I say slow, it's all relative. It's like 20 seconds a transaction or so. But when you have a lengthy list of transactions as a developer, you don't want to wait 20 seconds for each one of those to execute. But your code does need to account for how long it takes for these things to do that. So it's really important that at some point you're familiar with setting this up. And it's really easy because to run it, all you have to do is run this file and this takes care of it. It's going to set up that network, private network, and then you can start interacting with it as if it were the real deal. Maybe later on I'll create a separate webcast that covers this, because when you're working on a real Geth node, even if it's a private one, again, the rules are a little different. You have to create accounts, you have to mine, you have to get some Ether, things like that. So now compare that to test RPC. All you do is tell it run test RPC and how many accounts you want, and that's about it. So let's see if we're all done. Nope, it's still churning away. So, just so I don't mess up like I did the last time, we are going to set up our folder structure for what we're going to do next. Oh, okay, we're all done. So, let me drag this over here. Here's what I like to do. We should be able to run Truffle test RPC. So if I go into live coding result, cd live coding result, and was it in scripts? I think so. So again, if I wanted to launch Geth, all I'd have to do is /launch-geth.sh, and it would launch that instance, that private blockchain. We're not going to do that because I want to do things a little quicker. So instead I'm going to do launch-test-rpc.sh. Oops, I did this wrong. It's /, and I think that should do it. So this is how I know test RPC is running. So notice how it created 5 accounts. It created private keys, one for each of these accounts, and this thing is listening on localhost 8545. So let's come back to this window, because now we're ready to start setting up our contract. So we can just leave test RPC in the background. We're not really going to interact with this window. It's just something that needs to be running. So coming down to step 8, we are just going to, I'm just going to copy and paste these commands. So nothing, we're going to make a folder called dapps or dapps, whatever you want to call it. We'll go into it and make their Metacoin. That's just the name of my project that we're going to create. If you played with Truffle, even version 2, it comes with a default contract, the Metacoin contract. So that's why I'm naming this Metacoin. So if I go back into this, we'll see there's nothing in it. And here's where Truffle really gets nice. So what Truffle, when I issue this first command, what it's going to do is vomit out a bunch of files in this particular Metacoin folder. So it's basically going to create all the contract files and create all the packaging stuff that we're going to use to compile it, to deploy it to test RPC, and then to build out the web server part of it and actually launch it so we can interact with it. So again, the first part of this is Truffle init webpack, and that's just going to create the folder structure. Notice how it's listening on 80. You know, it's like it knew enough to know how to find my local port, so or local instance of what will be my test RPC. So if I look at these files, this is what that command just did. It built out this folder structure, and I don't want to get into this too much. So if I went into webpack.config.js or truffle.js, these are the settings that control the rest of the build and deployment process. So this is where I'm going to tell it, no, our get node is at 54. Something else, and if we had a bigger, more elaborate set of contracts, I would say, hey, our contract isn't called metacoin.sol. It's called my particular contract. So we'll get into some of those in another webcast. I just kind of want to motor through some of this. So next thing I'm going to run is Truffle compile. So these are the 3 Solidity files that are part of the Metacoin contracts. Now, here's where the fun begins. So migrate, this is the, actually before I do that, so look what this did, it put this build directory in here. And if we look in build, this just installed the contracts folder. So next command I'm going to run is truffle migrate. And what this is going to do is it's going to take these contracts that were in the build folder and deploy them to test RPC. So when I run this, we should see some activity over here. So I click enter there. Okay, so good news. So what it did is it deployed the contract over here and it grabbed the address of, I think this looks like the address. So now Truffle knows the contract lives here and it grabbed this address. So the last thing we need to do is run npm run build. And what this is going to do, now that we know the address, npm build is going to install more files in this build folder. So namely this app.js. So it's going to install a bunch of files in there. And that's going to tell it how, hey, I know the address we need to work with. I know where we're deployed. I know how to access the test RPC network, and so on and so forth. So at this point, we can start serving content. So you see in my document, I listed 2 options. I'm very new to Truffle Serve. I've only used it a couple times, and I'm not a big enough of an expert on Ubuntu. I don't know. I didn't have problems. I shut it down incorrectly one time, and then I had all these port conflict errors that I couldn't fix. And I found that using the PHP web server is a little more forgiving. So let's start this, and I have a feeling I might have to install this. Yeah, it's telling me I need to do that. So let me install PHP that thing. So what is it? Sudo apt get install that thing. So nothing magical there. Okay, so we're done there. So now I should be able to, where was that command? It was, yeah, it's PHP, copy and paste it again. I want to make sure I'm in the build folder, because that's where the index.html file is in that app.js. And at this point, we're serving files to our web server. So all we should have to do is come to a browser window and hit, oh, I gotta do port 8080, :8080. Here's our Metacoin example. Now, what's interesting is I don't know if I should go into this now so much or explain it a little more when we fix this. I think I'm just gonna fix it the ugly way right now, and we'll talk about it more in a later screencast. But basically, here's kind of what happened. When we went through all those 4 Truffle commands, it built this thing out thinking I access test RPC at localhost colon 8545. So the problem is, because we're running this on an Ubuntu instance at Amazon EC2. So I mean, imagine what happens. So all this code knows. Let me launch another window. Build. Yeah. So all this browser knows is what's served in app.js and index.html. Somewhere in app.js, it's saying, hey, I was told through this whole build set of commands we did, test RPC should be at localhost colon 8454. The problem is, my browser doesn't know where localhost is, because I'm just calling this web server. So my browser's trying to resolve localhost, and it's trying to find my own machine responding on port 8545, and that's not working. So without explaining this too much, I'm just going to fix one line of code. How do I do this there? App.js. So I'm going to do a Control W and look for localhost colon. And what this basically is saying on page load, we need to install, or we need to run this HTTP provider, which tells this app.js file where test RPC is, and so that's why it's failing right here. So again, bear with me. I'm just going to fix this a little more, or quick and dirty right now. We'll dive into this a little more, because there's a way to fix this when you build the files, and I haven't quite figured it out. So we'll figure that out in a later video. So there's 34205.64.145. So I think that should do it. I'm going to do Control O to save it, Control Z to get out. Let's refresh this. Hopefully we won't see any errors. Let's give it a second. We're looking good. And then the last thing I need to do is I want to grab a valid address. And remember when we first launched test RPC, it did echo the addresses. There's commands we can use to grab some of those addresses, but it's already here. So I'm just going to paste this here. And we're going to send 17 metacoins. We're not sending Ether. We're not sending Ethereum to this. Metacoin is its own fake coin that runs on top of Ethereum. And so we're sending 17 metacoins to another address. So we should see this go down by 17. So when I click send metacoin, and it did. So again, that kind of concludes what I wanted to do in this screencast. I just kind of wanted to show how to get Truffle up and running. I kind of hacked this thing together in the end, and I promise in a subsequent video I will figure out what files we need to change. And again, I'm 99% sure we're either going to change some stuff in truffle.js or webpack.config.js that's going to fix our problems, and so that the rest of the build process happens fluidly and we're not going to have to manually hack things up. But again, I'll save that for a separate video. Maybe I'll do that next. I'm not an expert at this. You can ask questions below and I will do my best to answer them. It's my hope that other people will watch this and chime in and help me answer some of those questions. But I think I'm kind of learning this as you're learning it. I doubt I'm that much further ahead than where any of you might be. So hope you stick around for some more videos, and again, ask questions if you will.